From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 99, recorded live Wednesday, February 6th, 2008. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Mac developer Stephen Frank.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm sitting here with Stephen Frank from Panic. Panic makes Mac software. Stephen and I went to college together, actually sat next to each other in college, and bought our Newtons on opening day. I remember we rushed down to, I think it was an Incredible Universe that they called it.
That's right, Incredible Universe.
We spent a ridiculous amount of money. I think it was about the equivalent of a term's worth of...
We're early adopters.
And we actually convinced ourselves that we were going to take notes in class. I remember we tried to put together C code in the notepad of the Newton.
I really tried. I honestly did.
Do you still have that Newton?
I still have, not that one, but I have kind of a small collection of them.
Really?
I got nostalgic and I bought one off eBay and just remember the good old times. And then somehow that turned into 4 of them because then I had to have one of each model.
Yeah.
And I don't know how it got started, but
still to this day, it's a fantastic thing. I've got my Newton syncing with Outlook on my system.
That's great.
Now, we were in a number of classes together, and if I remember correctly, we were in Windows GUI class.
I think so, yeah.
Now, I work for Microsoft, and you co-founded a award-winning Macintosh software company.
Yes, different paths.
Yeah. Was that class a part of it? Did learning how to do Hello World and 93 short lines of code and 16-bit Windows drive you away from the mothership?
Not really. I mean, you got to understand that I was always a little bit alternative. I don't know if you know this, but I was going home and doing my homework on my Amiga.
I did know that. I had suppressed that memory, but yes, that's true. That was the height of the Amiga.
Yeah. I mean, my first real computer was an Apple II, and my dad got a 286 or 386 at some point, and I got an Amiga with some money from my first job, and I was really into that for a while, and it kind of was hoping maybe it would catch on and be a big thing, but then it's pretty much disappeared.
It seems like the Amiga was the Betamax of systems. I mean, it was clearly superior, did amazing things with music and graphics, but just didn't catch on.
It just didn't catch on, I guess. It was, from what I've heard, it was kind of, the company was poorly managed. Commodore at the time was a lot of executives taking a whole lot of money and not putting a lot of money in where it was actually needed. Mm-hmm. But it was kind of very ahead of its time, and certainly when it came out, not a lot of computers could do the sorts of things it could do.
Now, so we were in C class together, and you were at home coding on your Amiga, so I assume you started coding for the Amiga directly.
That's right. Well, I mean, everything for class was, pretty generic, kind of standard I/O kind of stuff. But I did some GUI programming for the Amiga. One of my earliest jobs was for actually a Portland-based company that was a very small Amiga shop, where 2 or 3 people. And I wrote a terminal emulator, basically for calling up your BBSs.
Oh yeah.
For the Amiga. So that was kind of my first ever commercial software product. And I guess when the Amiga sort of disappeared, the Mac was the next sort of natural step for me, because I'd always, kind of wanted one. And when I got together with Cable, he actually had an old one that he let me use for a while we were getting rolling. And
Cable is the other co-founder of Panic.
That's right, Cable Sasser.
Okay, and you guys have a number of products, and I really started noticing you again when you started winning more and more awards. You get these little cubes from Steve Jobs.
I suppose that's one way of looking at it. It's called the Apple Design Award, and it's held at the yearly Worldwide Developers Conference that Apple holds in San Francisco now. It used to be San Jose. Mm-hmm. And there's multiple categories, things like Best macOS 10 User Experience, Best Adoption of Technologies in the latest version of macOS 10, and things of that nature, Best Student Project, things like that. And you get the cool little cube award, and you also get some hardware usually with that, like you get a couple of Macs or a couple of laptops or something like that, which is great because hardware is like our number one expense here. So,
Really?
yeah.
How many of those awards do you have?
We have, let's see, I think we have 5 total. A couple of them are runners up. Most recently, we got one for Coda at last year's WWDC, which was, I think, for best macOS 10 user experience.
Okay.
Coda being our website IDE, if you will.
Okay, so let's talk about Coda.
Uh-huh.
So my listeners are mostly Windows people, although everyone is a closet Mac head in the sense that they've got a Mac Mini or they've got a Mac around the house. I've got 2 Macs at home. And, I'm actually doing some beta testing of Office 2008, which is that released now?
I think it just came out, yeah.
Yeah. And it's such a different user experience. But I'm always interested from a developer's perspective about understanding other ways to do things. I explore Ruby and I look at Python. And I don't understand how you guys are writing this stuff. So Coda is a big full-fledged IDE, but you also use componentry from other companies.
That's
like
right.
CSS edit and you pull in different things. So help me out, help me understand Mac development from like DNA up till this afternoon, because do you have a component model? How do you have inter-process communication? Is this all just in C? It's magic as far as I'm concerned.
Well, most of you mentioned the licensing of code. There was a text editor product called Sabetha Edit, which came out years ago now on the Mac, and it was a collaborative text editing environment. So you had multiple people on the local network all editing the same document at once, and it would update on real time on everyone's system. That was a really interesting idea. We talked to those guys about licensing their engine because it already did that collaboration functionality, which we thought would be really useful in an IDE. And so we just worked out sort of a private deal with them to share their source code with us. And so it's not quite as componentized as I would like. We basically have the source to their application, and then we compile into our project the bits that we need.
That's not quite as glamorous as I thought. I mean, if they update their source, which I'm sure that they do, you're going to have to do source level diffs.
Yeah, we do a lot of that type of merging.
So how do you share stuff? I mean, if I was going to write a spell checker or an IntelliSense tool that's going to allow you to plug in a new language, in what format does that look? What does that look like?
Well, for collaboration and stuff, we use Subversion. Almost all of our code, like 98% of it, is in Objective-C.
Okay. But what I'm asking is if I'm going to make you a component, I want to give you the binary.
Okay.
So let's say you get into Subversion, it's in, you've got your /source, but you've got /lib. I give you a what? It's not a DLL, it's a lib, or it's just, what is it?
Well, there exists a thing called a framework, which is either statically or dynamically loadable, which would be similar to a DLL. You could do it that way. We tend to build our apps sort of monolithically so that everything's compiled in, except where we can't do it for things like the LGPL, where we're required to dynamically load.
Okay. So give me an example of an LGPL thing that would stay out of your application and sit next to it rather than inside it.
What's in there? I think Neon, for example, is in there. Neon is an LGPL library for doing WebDAV connections, which we use in both Coda and Transmit.
Transmit's your FTP client.
That's right. And so one of the terms of the LGPL is that you have to be able to provide the source to any modifications that you make to it. And you can, by not statically linking it with your application, you can provide just the modifications to the library itself and not your whole application. You don't have to give out the source for. So that's one thing that we compile into a dynamically loaded bundle or framework, as it's called.
Okay. And when you use those from code, once they're loaded, they don't look any different. I mean, you don't have to go hunting for proc. I remember when we were doing these things, we would load library and get proc address. You'd find entry points, and you have basically .h files describing what's in that thing over there.
Right.
Do you have that experience too?
Not really. Once the bundle's loaded into the main application, it's available, and you can just call into it like you would any other class.
Okay, so this is a real common thing. So bundles are a very common way for people to have a component model from place to place. Now, are those typically loaded out of the same folder as the application, or is there a central store for those things?
Well, there's 2 ways you can do it. There's sort of a global library folder which contains things like the WebKit framework, for example, which is the Safari web browser's rendering engine.
Okay, so the rendering engine kind of comes with the OS. That's right. So it's kind of like the way that Internet Explorer, there was that whole lawsuit, and they said, Internet Explorer comes with the OS. But for us, it's a thing called Shell Doc View, and it's like the thing that renders HTML.
Right.
It's over there, and it was associated with the entire system.
That's right. Yeah, it's installed in the system library.
Okay. So I can use that in my application. I don't have to worry that it's not there. It'll always be there.
Right. You don't know necessarily what version will be there. You usually you can look at things like the top level OS version, is it 10.4, 10.5? But there can also be interim updates to Safari in that time that will update the WebKit framework.
Okay. So there's those libraries that are shared.
Mm-hmm. And then there's a user level library folder where you can install things like that into, but it's not a great idea to do so because then you end up with, dependency problems and things like that. And it's just generally something Mac users don't want to worry or care or think about. And so the other option is you can embed the framework into the application directly. And this is kind of the interesting thing about the application framework on Mac OS X is it's at its root, it's just a folder structure. So you have, like in our case, our application Coda has a root folder called coda.app, which is displayed to the user as a single icon, the little leaf that says Coda underneath.
So this thing about directories is really interesting to me because when I go into the Finder, which is like the Windows Explorer, and I see an icon that says Coda, it's a leaf, I guess, right?
Mm-hmm.
That's a lie. It's really a folder called coda.app.
Well, I wouldn't say
I don't say it's a lie. Like it's a bad thing because we do the same thing in the Windows world. There's a thing called an Explorer namespace extension where you're going around folder, and then you see a folder that's a special kind of folder, and you go in it, and you basically get a pair of rose-colored glasses over reality because reality is just not relevant.
Well, it's only a lie if you consider each icon representing a single thing. Do you know what I mean? Like, there's still, it's one icon representing this concept of an entire application. So
but double clicking on it runs it. It doesn't go in there.
That's right.
Okay.
And I'm trying to figure out how I'm wording
maybe
this.
Lie is not the right way to put it. But what I'm saying is that,
yes, it doesn't.
That it's, if you put .app on the end of something, does it automatically turn into an icon and not a folder?
Sort of. It'll probably get very confused if it's not actually an
Is there some kind of,
folder.
I assume there's a manifest of some kind, and there's
Right.
let me say this, rather than a lie, it's a convention.
Yeah.
But it's a time-trusted convention. Did it begin with OS X?
Yeah, I believe it comes from the Next Step origins of,
really?
of Mac OS X, yeah.
I remember playing with Next Steps in high school, but I don't remember ever getting into that detail about how it actually worked.
Yeah.
Okay. So when you drag, when I get when I download something from a Mac shareware site, I get a DMG file, a disk image, like an ISO, right?
Usually, yeah.
I open it up, I see an icon, I drag the icon into the applications folder.
Mm-hmm.
Was it really an icon, or was it just moving one folder to another folder?
That was literally a directory copy from the read-only disk image into your applications folder.
So on Windows, we're always running installers.
Yes.
And we're putting, we're changing the registry, which is a central storage location, and we're laying files down, but we're also checking to make sure shared libraries are available. Mm-hmm. How would an application in the Mac world do those things?
As a general rule, we're very anti-installer. For one, it annoys me greatly if an app requires an installer and it doesn't actually need one. Like some companies who kind of don't know what they're doing with Mac development, they'll build their app and then they'll put it in an installer and it doesn't need one. You just copy it you just drag it off into the applications folder and that's all you need to do. But there are exceptions to that. Things like drivers, specifically would have to be copied. They're usually in the form of kernel extensions, and those have to be copied to a specific folder to make them work.
What's a kernel extension in this context?
It's, it would be something like a driver for a Wacom tablet.
Okay. So kernel extension in the context of Linux and Mac OS is something that runs at ring 0.
Basically, yeah.
Okay.
It's literally loading into the kernel and providing some extra support for hardware or whatever.
And are those the kinds of things that can crash a Mac?
Yeah, those will get you into like kernel panics and the only real hard kinds of crashes that you can have.
So a kernel panic, that's like our blue screen.
Basically, yeah.
Okay.
You see it. I don't know if you've ever seen one on your Mini, but
I got a sad Mac once. But
oh, really?
Something else.
Well, that's
I
like a
had
hardware
bad
failure.
memory. Yeah.
Kernel panic is like the whole screen darkens and you see a message in every language that is supported by Mac OS X that says, please restart.
I did get that. And it's like Japanese and Chinese and the whole thing. Oh, okay. That's a kernel panic.
Yeah, that means something really bad happened.
Okay, I must have plugged something in.
Okay. So anyway, and in terms of checking for dependencies and things like that, usually if there's something really special you need, you would either bundle it into your application.
Well, let me ask this. Go back to WebKit. So you were saying that you might want to use that library, make that service, that system-level service wants to be available, but maybe you really want a certain version of that and you don't have it available. What do you do?
Well, what I'd probably do is check for it at runtime.
Okay.
And then that gives you the opportunity to pop up a nice explanatory, like, I need this version of Safari to be installed or I can't run.
And then you send them off to go get it.
Right. But that rarely happens.
Does that happen because it seems like Mac applications say we work on this dot release of OS X?
Yeah.
Full stop.
Yeah.
And like on the Windows world, and I'm juxtaposing I'm not intending for to talk Windows up or talk Mac down.
Oh, sure.
We're just juxtaposing. In the Windows world, there are times when we'll say this app only supports Vista. And there are very rare but a few apps where they only support like Vista Service Pack 1, which would be like, I think it's OS 5.2 or something like that. Vista has a number underneath it. That's the real number too.
Right.
But most often, Windows users really want compatibility because you've got like Windows 95 people out there.
Right.
So in my world, we're always talking about how can I get this application to run on 95, 98, 2000,
right.
Mac users, it seems like you guys are more relaxed about that. And if it doesn't run on OS 10.5, well, I'll just upgrade it to 10.5. Why is that? Is it
for some reason Mac users are very, I won't say early adopters, but they don't seem to be very afraid of upgrading to the latest version of Mac OS X.
Haven't been burned by the upgrades. And they work.
Really,
they mostly work, right?
Yeah.
I mean, I upgraded to Leopard, right? That's 10.5.
10.5.
And, everything pretty much worked. I lost classic mode, so I can't run my old applications anymore.
Right.
KidPix was a casualty of that.
Oh, really?
Quite a bummer. But I looked around the net, and it wasn't like a lot of people were up in arms about the loss of KidPix.
Right. Most people by now, I think, have got replacements for all of their classic apps, and they're pretty much done with it.
Okay. Very progressive bunch.
Except for, of course, the Newton users who are still desperately trying to use the connection utilities.
That's true. Okay, so back to the structure. So there's Coda has coda.app, and there's a directory, and then is that as far as the convention goes, or is there a convention for things living inside that directory?
No, there's a convention for basically the whole structure of that folder. So within that, you have there's usually a folder called contents, which I think is sort of vestigial because it's usually like the first and only thing in the top level. And then within that contents folder, you'll have the actual binary for the application. You'll have a thing called the info.plist, which is a property list file, which is basically XML or like a binary.
So this is a formalized metadata, kind of a sidecar.
Yeah.
It's along for the ride.
Yeah. It says sort of, here's the name of the app, here's the copyright information, here's the path to the executable.
Now, didn't these used to be in what they called the resource stream? Maybe I'm using my Mac terms wrong, but I seem to remember that the files had multiple streams within one place. File. Forks. There you go. The resource fork. Thank you.
It's kind of
separate files.
It's kind of an obsolete now, but that was the macOS file system, which is called HFS, supported this notion of forked files. So you have a single file, again, a single icon that has multiple forks on disk. So it would typically be just two, the data fork and the resource fork. And in the very, very early days, like, original black and white Mac, pretty much everything would be resource based. Like your compiled binary code would be in a code resource. Your menu layouts and your UI layouts would be in other different types of resources. Your fonts would be in there. But it kind of created a world of pain when dealing with other OSs, and because you would have to find a way to collapse these two different sections of this file.
Exactly. Well, I was always running Mac Opener, and I'd find what I thought was one file was two or three.
Yeah. And that's kind of a bit of legacy Mac voodoo that's not real common anymore. You still occasionally see things with resource forks. Ironically, usually the bigger development houses, Microsoft and Adobe, you'll sometimes see them sort of because they have so much code to migrate towards the way things are working now that it takes them a while to get there. But I think most everyone is moved away from that now, which is, I think, a good thing.
So is the result of your build, I mean, do you have daily builds, and is the result of your build this directory structure?
For some of our applications, we do have a cron process that runs nightly and spits out a new build. And yeah, the output is the .app.
And how do you look in there? I mean, you have to get the development SDK to say, I don't want you to look like an icon right now. I need to be poking around in here for debugging purposes.
You can actually do it with the regular Finder if you control click on an icon and
really?
show package contents.
So control click, show package contents, and that takes the glasses off, and I see reality.
That'll open it like it's a regular folder.
I'm going to do that immediately.
You can poke around. But that's also where inside that directory bundle, you also have things like loadable frameworks and things like that. So if you have something equivalent to a DLL and you want to package it in with your application, so that when the user drags that icon into the applications folder, it comes along for the ride. So it's sort of a standardized way of just packaging an executable and all of its dependent resources.
And two really interesting transitions have happened in the last couple of years in Mac. The first was the introduction of Intel, which seemed to go very smoothly. And then there was the introduction of 64-bit. And in both of these instances, it doesn't seem like, my mom and those kind of users has really sweated it. What are the kinds of things that made that possible, and what are the things that didn't work that were actually very painful from a developer's perspective? Because there was this PowerPC to Intel, which I assume was new compilers and new libraries and new everything, and some things worked and some things didn't. And then now I understand that 10.5 is 64-bit. There must be a 32-bit thunking layer, and there must be some 32-bit, processes that are running.
Well, to get back to the CPU for a second, it's interesting. This is actually the second, if you think about it, CPU architecture change that the Mac has had, being the first being 68,000 series to PowerPC. So we've kind of been around that block once already.
True.
And they came up with some, creative stuff there. And and even before that, if you go way back, there was a switch from 24-bit to 32-bit addressing, which broke all the apps that were like, hey, we could, store extra stuff in this byte. So yeah, the thing about the CPU architecture change is that we've actually done this once before with the 68,000 to the PowerPC. And so we kind of been around this block a little bit, and they came up with lots of creative tricks, to get us up and running on PowerPC, and broke everyone who was, trying to store data in the extra byte of their 24-bit addresses. And
was that a painful time? I mean, from the user's point of view, I assume things got worked out, but as a developer, just things fell apart?
Everything had mostly gone to PowerPC by the time I came along. So I didn't catch too much of that, but there was still a lot of transition even at that time. They were getting rid of the traditional Mac TCP stack and moving to something called Open Transport that was all stream based, and so a lot of people were having to bridge their network code depending on whether you had Mac TCP or Open Transport loaded. Oh god, this is also long ago. Painful memories.
But recently, your company had to deal with the transition from PowerPC to Intel, though.
Yeah.
So as the co-owner of a company, when that happens, it's like, okay, here's what's coming down.
Everyone was pretty nervous when it was announced, because it's like, wow, that sounds like a big change, and Indianness and all that. And what they did was they started out by shipping everyone sort of what they called a transition developer kit, which was a very early, like Cro-Magnon, Intel Mac that was running a Mac OS X build on Intel. And what the first thing that was immediately noticeable was that it all just worked. Like, it wasn't doing weird crashy things, and it was just Mac OS X with a different CPU, which is kind of
and different Indianness, which, I mean, people can't overestimate.
Yeah,
Indianness will bite you.
Oh yeah,
depending on how you store your data.
Yeah, and so that was the most impressive thing, was it just ran like it did on PowerPC in terms of the OS, and there wasn't really any if you had sat a Mac user down in front of it, they wouldn't have known anything was different really, other than it was a bit faster.
And that's the magic of compilation. I mean, C is a portable language, and as long as you think about, I mean, I've done C programming on the Palm Pilot, which I think was a 68,000 at the time.
Probably.
I ran into Indianness when I was doing my shareware license keys.
Right.
I generated them on my PC, and
God.
I had to confirm them on my Palm Pilot, and it didn't work.
Yep.
And it was all written in C on both sides. And I said, if Big Endian,
Yep.
do this. And
Exactly.
a little if-def and you're cool. Was that what it was? New compilers and some if-defs?
That was kind of it. It was surprisingly painless. Like, there were a few Endian things, and I think they were serial numbers for us as well.
Really, yeah. I mean, how many times do you have to think about things in terms of bits and bytes?
Never really. I mean, we deal with a lot of network code, and there's such thing as network byte order, which is,
Right.
Things are done a certain way there, and so we didn't have to worry about that. Our stuff's not real CPU intensive for the most part, so there wasn't a lot of mathematical algorithms that we had to that were hand optimized assembler or anything like that. We mostly just called into the APIs, and I think if you did that, everything mostly went fine.
Yeah, the same thing happened on the Palm. The Palm changed from one CPU to another. I think they went from a 68,000 to a small ARM processor, and I wasn't playing well. I was writing directly to video memory, and I paid the price. Well, all my friends in the Palm community were writing to the APIs, and that's really it. I mean, when you're writing any kind of a kit, support those public APIs, and things will usually work out.
Yeah, they always tell you, use the APIs, don't touch the hardware, and you're like, yeah, whatever, I'll touch the hardware, and then something like this eventually comes along. So
what about the 32 to 64-bit transition?
I'm not probably the best person in the world to talk about it, since my 64-bit experience is kind of limited.
Well, you're running Leopard.
Yep.
And you're running it on a Core 2 Duo.
Yep.
And does the OS support letting you know whether or not a process is running 64-bit or not?
I believe the way it's managed is the same way that you can ship an app that runs on both PowerPC and Intel, and that's done through what they call the FAT binary.
This is this universal binary that everyone was shipping.
Right, exactly.
And they were complaining that Adobe wasn't stepping up and shipping universal binary versions of stuff.
Right. It was not until CS3 came out that Adobe was shipping an Intel native version of their suite. Which
CS3 is Creative Suite version 3?
Creative Suite 3, yeah, which is Photoshop and Illustrator and all that.
So a universal binary is just more of this same, this .app thing where you have a hidden folder, and then they just had two versions, one for PowerPC and one for Intel?
It basically compiles twice. It compiles once targeting PowerPC, compiles once targeting Intel. And then at the end, it runs a program that basically just kind of glues them together into one binary. And then the loader, when you launch your app, knows what architecture it's running on, obviously, and loads the correct binary.
That's interesting that they have the convention for having this folders in the .app thing, but rather than having side-by-side binaries, they actually melded them together into one.
Yeah, that is kind of interesting, because it seems like there's an allowance in the folder structure to have multiple binaries, and there is actually like a macOS folder within that seems like, you could have subfolders.
Yeah.
And they didn't, I'm not sure why they didn't go that route. I'm sure there's probably maybe a performance reason, but.
And have there been problems where you've debugged the system only on the PowerPC version?
Well, yeah, I mean, during the transition, it was hard because you would kind of also have to do testing on both platforms. And so it was kind of a chore, and every once in a while we'd miss something, but yeah, they're separate and distinct binaries that have been compiled, differently.
So for the most part, those things just work.
Yeah, and I think 64-bit works more or less the same way. So there's a 32-bit and 64-bit version of the system frameworks, the system APIs, and then it dynamically loads your 64-bit version if you have one, and dynamically links it to the 64-bit version of the APIs.
And is that something that like Coda and your different applications have done yet, or are you still 32-bit?
I think, as far as I know, we're still 32-bit on our apps because they're not very compute intensive.
Right. So unless you need piles of memory, and people don't really care. Right. Now on the PC side, we the .NET programmers do everything talking to an intermediate format, like a bytecode, like a Java bytecode. It's called IL, intermediate language. So we write C# or VB or whatever, IronPython, and it compiles to this IL, which is then JITted by either a 64-bit or 32-bit jitter.
Oh, interesting.
So we don't think about it either, but we only ship the one thing.
Mm-hmm.
But we have a flag that you can mark, and you can say, this executable is just 32-bit, or this one's just 64, or this one's any CPU. And the any CPU flag is that kind of magic bit. You do that,
I see.
you ship your exe, and it gets JITted just in time, and then lined up with 2 different versions, like you said, 2 different versions of the framework.
So that's like your universal binary.
Yeah, exactly. So the fact that it's not really machine code
Mm-hmm.
is the compilation. Let me put it this way. The compilation step that you speak of, where you have to compile 2 versions, that is left to the user's computer to do at the load time. And then it spins off. But we get nailed when, for example, a 64-bit process might accidentally call down into some 32-bit thing.
Yeah, I see.
It's called p-invoking. We're basically we're living in this higher level of abstraction, and as soon as we decide to break the fourth wall and start poking around, then you get hurt.
Yeah, sure.
Now, if you guys were in the business of doing drivers, I assume you'd have to be thoughtful about what was going on in the kernel, and there'd be 64-bit drivers and 32-bit drivers.
Yeah, I imagine so. We've never gone down that road, but
So for the app developer, you're just using is it Xcode and Objective-C? That's your primary development environment?
that's right. Yeah, Xcode is an IDE that Apple provides that does basically everything you need.
So it's like Visual Studio. It's the Apple Visual Studio.
Yeah, in a way, yeah.
And so the people that are writing desktop Mac applications, they use Xcode. Do they use anything else, or is it almost always Xcode?
It's pretty much always Xcode. There aren't any real alternatives to it yet, which is kind of odd. I guess the market is so small that no one's really seen a financial opportunity there.
Mm-hmm.
I mean, you could also go sort of a classic Unix route and have something with a make file and and do your editing in a whatever editor you want. But most people tend to use Xcode just because it's all nice one place.
Yeah, so it's got the momentum. It sounds like Visual Studio in that context. I mean, there are alternatives, but
The big compiler or IDE used to be CodeWarrior. And then macOS 10 came along and it sort of killed CodeWarrior because they just weren't ready for it. And
yeah, MetroWorks, CodeWarrior. I did all my Palm work in MetroWorks.
Really?
Yeah, I love that.
yeah.
It was a good idea. Yeah, it was fine.
I don't know if they still exist. For a while, they switched to just doing like embedded stuff only, like Palm and things like that.
I mean, they really were targeting the processor
Yeah.
at that point.
Yeah.
So yeah, when the processor market changed for Mac, they went away. So when I hear Objective-C, I think low level, and I think, oh god, it's C, and what kind of pointer dereferencing must Stephen have to deal with every day? Is this ignorance on my part? I'm sure.
Objective-C is real interesting because your first reaction is to look at it and sort of run screaming because there's like these brackets everywhere, and I know that was my reaction. But I've over time like really come to enjoy it, and it's like one of my favorite languages now. And all it is straight C with a little bit of an extra syntax layer. So it gives you an object model, and it gives you things like all the things that you would expect from an object-oriented language. And interestingly enough, Leopard introduces Objective-C 2, which is, so I should back up. Objective-C has it's the language, but there's also the runtime, which is a crucial component because it's a very dynamic.
Okay, so I'm used to C and the C runtime, that you always have a C runtime on whatever platform you're targeting.
Right.
So you have the Objective-C runtime, which is, I'm sure, all of that plus more.
Right. And that's what handles like, here's these classes that are available. And when you send a message to a class and like figuring out what the actual, who it gets sent to and all that good stuff. So that's the Objective-C runtime. And in Leopard, that was revved to support things like garbage collection and some other kind of nice additional things.
Oh, really? So you can make a string and don't worry about dereferencing it later. You don't have to go malloc and then free.
Right. Generally, the historically the method has been that you would have like an object called myObject, and you would say myObject alloc init. And so alloc does the is essentially the malloc, and then init sets it up with initializes the variables and all that stuff.
Right. So then C++, you make your class, you go new class, and then the constructor happens. It's implied.
Exactly.
Is this Objective-C or is this Objective-C++?
There's both. I don't know anyone who uses Objective-C++, but I think it's mainly if you have existing C++ code that you want to make run in an Objective-C world.
But are you using structs or classes? I mean, do your structures have behavior?
No, structs are just regular C structs. Objective-C has its own class concept that it uses. And it's all very dynamic, so you can do like goofy things like swapping out one class for another at runtime and having one class pose as another class and various tricks like that, depending on how deep of a hole you want to dig for yourself.
Do you do interfaces? Do you like define an interface and say that any one of these three guys will implement that interface, so any of them is suitable for pluggable componentry?
Like a subclassable type of...
Not subclass in the abstract base class sense. Like, I mean, you could go and say public class person and then derive tall guy, short guy. Or I'm thinking more public interface I person, where I will accept anyone who has this method signature. If you're an object and you have first name and last name, as far as I'm concerned, you're a person, and that's cool.
Yeah, you could do something like that. In fact, if you want, you can even go a little lower than that. You can say, does this object respond to this message? And if so, I want to send it this message. It's actually distantly derivative from Smalltalk, which is
really,
and kind of related languages along the way, like self and this concept of objects and sending messages to objects.
Okay,
but in a very dynamic way, so things are not very...
Yeah, that sounds very kind of Ruby-esque, because then you can go and say, method missing, where you'll say, I'm the handler for any objects that this object doesn't, any messages this object doesn't know how to understand.
Yeah, you could do something like that, or a lot of times there's a concept of a delegate object, especially in the user interface. Like the embeddable web view is a traditional example of that. You'd stick this, okay, this is a view class, so it's going to be view things only, not model things. And then you say, okay, but this view has delegates. And like it might have, for example, a policy delegate, which is when someone clicks on a link that opens in a new window, what should I do? And then that's sort of a callback in a sense.
Okay, this is good. So let's bring this full circle, because we were talking about the WebKit, which is the Apple, HTML renderer. So I'm going to write an application, and I go into Xcode and I go file new project, and I'm going to make a new Apple application, and I want to use the WebKit, and I bring this. I get this on the form somewhere in the dialog in my resources.
Right. The program's interface builder, which is the UI layout.
So you have a separate kind of resource fork. That's not the right word, but dialogues are described in a declarative way.
Right. There's a visual editor called Interface Builder that generates what are called nib files. I think it comes from Next Interface Builder.
I've landed on Mars. Nib files, and it's so interesting to learn about other cultures.
Yeah, exactly.
And so then I want to basically make a web browser. So I put a couple of buttons on there. They're my buttons, not WebKit buttons. I put the WebKit white area that says HTML will go here. Put in a text box. Do I wire up events and I say, when I hit go, grab the URL out of that text box and tell WebKit to go get it?
Yeah, you can do the codeless web browser by essentially connecting the text box to the web view and saying, when this text is entered, use it as the URL.
And I'm sending messages at this point?
Yeah, it will. When you update the text field, it will send a message to the web view to...
Really? And I do that codeless, like you did?
Yeah, codeless.
Okay, so the interface builder knows enough about the messages that these various components provide.
That's right.
And their properties that I can line them up very neatly.
Yeah. And it's only when you need to get fancier that you start to add, code in there for your...
So you're grinning, which means that codeless, just like with Microsoft, it's a fun demo, but it quickly doesn't work and you got to get into the real work.
It works for a surprising number of things. But yeah, to get into any real nitty gritty, you're going to have to add some code at some point. There's a real interesting new concept that actually started one version prior to Leopard on Tiger, which is called bindings, which was the sense that, okay, we have all of these model objects that are kind of standardized system level things.
Right.
And we have these views, which are system standard, but we don't have any sort of standard controller layer. And so the notion of bindings was to say, it's a notification system. So a model can say, I changed my value, and then all the views that are listening to that model automatically hear that and update themselves and go the other way. If someone changes the view, it propagates all that information back to the model.
That's interesting. I'm trying to find parallels because we've got things. There's so many different ways to pass messages. I mean, with all OSs, there's like a half dozen different ways with mail slots or pipes or whatever. God knows what's going on. Which gets me thinking about backward compatibility because one of the things, and don't take this the wrong way, right?
Sure.
I mean, I've known you long enough that you won't be offended, but it just seems like, and I thought this before I worked for Microsoft, and now I think it even more, that it really bugs me when people get mad when we're going to yank support for Windows 95 or Windows 2000, because those things, Windows 95 is 13 years old, and I feel that we should be able to yank, and I'm sure we've yanked, I don't know what the support life cycle is, I'm sure we've yanked support for that, but Mac users don't seem to get too mad when you yank something that out from under them that's only a couple of years old.
It is interesting.
And you do, I mean, as a Mac person who really could care less about Windows, you do see the hypocrisy in that.
I do, yeah.
Okay.
And it's not just software. Like when the iMac came out, it had no floppy drive. Oh my God.
Yeah.
It has no floppy drive. What are we going to do? Like everyone freaked out about the iMac having no floppy drive, and it has made absolutely no difference.
Well, now they're freaking out because the MacBook Air has no optical drive.
Right. And no Ethernet jack.
Well, that's different.
Yeah, and it's one of those things that there's a level of like, oh my God, what are we going to do? And then I think over time people find out that it's really not that necessary. And but to get back to more the software side of things, yeah, they have been very aggressive about dropping backwards compatibility. I mean, we went from the classic versions of Mac OS went up to 8 and then 9, and then there was this there was the transition to PowerPC there, which for the most part worked. Your applications would just work, and then this massive switch to Mac OS 10, completely different universe.
What were you running in 2000? What was the Mac world running in the year 2000?
2000, that was like right in the middle of that switch over.
Okay, so if I'm running Mac OS 10.0,
yeah,
right now, which would be like Windows 2000, do I get any love in the Mac community, or do I have there's no sympathy for me?
No, you basically nothing will run on you except probably what came with the OS.
Really?
But I mean, we survey our users from time to time. We have like an opt-in. We'll send, collect stats or whatever.
Yeah.
And there's 0 people running Mac OS 10.0.
0.
It's the current version and one version back accounts for probably about 95%.
Right. And these are minor versions. Like there's 10.5 and 10.4.
10.4. Yeah.
So this would be like Windows saying it will only work on Vista Service Pack 1 and Vista, and everyone else is screwed.
Kind of, yeah.
And people have petitions like Save XP.
Right.
I think I guess it's because they're so big. I mean, there's businesses like, I always use this canonical example, which is I don't know if this guy really exists because I've been talking about this theoretical, the chief architect of the Nebraska Department of Forestry.
Mm-hmm.
This is my, my prototype guy.
Yeah.
And he's the guy who's got Windows 98 machines running Access that have important data that is fundamental to his business.
Yeah.
And I always wonder, he doesn't want to upgrade because he doesn't want to mess anything up. I always wonder if there's the same Mac guy out there. The System 7 guy who's running like HyperCard and all his data is there. And if he upgrades, it'll be over.
We hear from them from time to time, but they, percentage-wise, as far as we can tell, they're a very small minority.
Yeah. Well, now that you guys, when we say you guys, I mean Mac folks, have gone from like 3% to like, 12 or 13%.
At least 10, I think now. I don't.
When do you think this is going to bite Steve in the butt? When there are many millions of people who are not really interested in upgrading.
Well, this is the thing I was thinking about Windows over lunch today is that they, you've still got, I think, in the properties dialog, options for DOS compatibility mode and all this stuff because somebody's like horrible.
Yeah. Even on Vista, you can run VisiCalc.
Yeah, like someone's terrible point of sale DOS-based, thing is going to break if they get rid of that. And I don't know what you do about that if you're Microsoft.
We suffer, dude.
You're stuck. I mean,
it totally sucks.
Which is interesting. And I guess that is, to a point, a function of market share. And I'm glad I don't have to be the one who has to decide the path forward on that.
Not yet. I mean, I just think that at some point, people won't take it anymore.
Yeah.
At some point, Mac will get big enough or Ubuntu or whatever. And it's just, someone's going to get mad and they're going to say, no, we want support.
I mean, if you think about it, it's people want it both ways. They want to be able to run every program they've ever written.
Yeah, exactly.
That's ever been written
and
since the beginning of time. But they also don't want it to crash.
Yeah.
Everything has to just work out of the box.
Yeah.
All drivers should magically just work.
Yeah, you can't win. Like there's this game right now. I don't know if you guys have this on the Mac. It's called Crysis.
I don't think so yet.
It's from the guys that made Far Cry.
It's a very, very high-end game, right? Yeah.
Well, so this is not just a high-end game.
Yeah.
This is a game that was like sent back by Sarah Connor from the future. You know, it's
Right.
like some theory, and it literally runs on theoretical hardware.
Nice.
I mean, I have a quad proc
Wow.
machine with, you know, God's own video card.
Right.
And I've got like a little SLI thing going between the two video cards so they can work together as a team.
Nice.
In order to, and I still drop frames on this game.
Wow.
And people are complaining,
Wow.
you know, and of course time will pass.
Yeah.
And
It'll get there.
and the hardware will happen. And then we'll go, how do we ever live without this kind of hardware? My dad's got a quad proc machine. He can't get anything done.
Yep, exactly.
But, gosh, yeah, we should talk again sometime about things like multi-core and what that means and how Objective-C is going to deal with that. Because we're doing some really interesting things where you could take like a for loop and add a parallel keyword, and then it'll just magically work across multiple,
Oh, that's cool.
you know, procs. So I'm going to be interested to see, like, I'm sure you have multiple threads and you have to deal with multi-threading and stuff like that. But
Yeah, threads usually automatically branch off onto their own CPUs, but I've not seen anything at like the for loop level. That's pretty cool.
well, thanks for letting me come down and visit Panic headquarters, Stephen Frank.
Hey, no problem.
And this has been another episode of Hansel Minutes, and we'll see you again next week.